Hey everybody, so this is going to be for the Geometry Puzzles Day. This was either Thursday or Friday, April 15th or 16th. So the idea is what we're going to do. We're going to use facts that we know to figure out missing angles or sides or something else. So here's an example. This triangle shown here, there's something wrong with it. And I said, what's wrong with it? And what's wrong with it, take a second to look. If you haven't, pause it. If you add up these angles here, if you add 70 degrees plus 70 degrees plus 50 degrees, well, here you would get 140, and 140 plus 50 would get you 190 degrees, which is too big because we know the sum of the angles in a triangle should be 180. So your explanation might look like this. The sum of the angles, geez, typing on an iPad, in a triangle should be 180 degrees, the sum. And again, that just means to add up. These sum to 190, which is too many. And you can even see it if you look right here. There's like that little bit. I made this not quite accurate intentionally so that it would be that. But so we're going to use the fact that we know that this should be 180 to figure out what the problem is. With all of these, you should definitely try them yourself first, but by all means use this video to help you. So here the question was, which triangle has the largest area and how would you know? So pause the video and figure out what you think first. And then unpause the video. And the truth is that they're all the same. Yeah, they're all the same. They all have a base of 2 units. So if you look over here, we've got 2 units, 2 units, and 2 units, and they all have a height of 3. So like if you look, this right here is 3, this right here down the middle is also 3, and this height is 3. You're not using the edge. You're not using one of the other side lengths. It's just a vertical up and down height. And so in this case, since this is the formula for the area of a triangle, they would all have an area of base of 2 times height of 3 divided by 2, which is equal to 3 units squared. Please try this one again on your own first, but as you're going through this, you might notice that all side lengths are measured as the exact same. And in Desmos, you can actually like move around these, like you could grab B and drag it around so that you could see that these would change with that. And if that's the case, because we know that the sum of the angles in a triangle is 180, and this is an equilateral triangle because all 3 sides are the same, that means all of the angles must be equal. So 180 divided by 3 is 60, and we know that the angle A should be 60 degrees. In this case, you are told that ABDC, so ABDC is a square. What is the measure of angle DAB? So this little orange angle that we're indicating right here. Well, since this is a square, we know a fair number of things about this quadrilateral. We know that all of the sides are equal in length. We know that each angle is 90 degrees in total. And if that's the case, this line between A and D evenly divides this angle. And since this is a 90-degree angle, we could just say that that is going to be 90 degrees divided by 2, which is equal to 45 degrees. That is one way to solve this. I also saw some students who came up with brilliant thinking where they said, well, this triangle right here, the triangle DAB, the whole triangle, it's got a 90-degree angle right here. We know that that's 90 degrees. And that means that this green angle and this orange angle that we've got over here must be equal. And so if you say the sum of the angles in a triangle is 180 minus that 90-degree angle that we've got over there, we know that there is a total of 90 degrees left for both the green and the orange, and then you still are at this 90 divided by 2, which is 45. So your explanation here could be any of those. There's probably even more. So here, before I sent students off to kind of work by themselves, these problems up till now we'd kind of done together. I wanted to make sure everybody had these things written down. So the sum of the angles in a triangle is 180 degrees. Each angle in a square is 90 degrees, and a straight angle has a sum or a total of 180 degrees. A straight angle is just like if you literally have a straight line and we're asking about this angle right here. And the reason that you might want to know about that is, imagine if you had an angle like this, and I told you, hey everybody, this angle right here is 110 degrees, and I asked you, what's that angle? You'd say, oh, well, I know that. It's just going to be 180 minus 110, which is 70 degrees. And so I could know that this right here would have to be 70 degrees. And then we just kind of asked if there were other ideas. So if you have anything else that you think might be useful, by all means, throw it in there. Here we have a parallelogram. That means that this side length and this side length are parallel, and so are these. And it is inside a square, so I know that we've got those 90-degree angles again. I know that all of the side lengths are the same. And I've told you here pretty clearly that this is a midpoint and this is a midpoint. That means that this length right here is equal in distance to this length right here. Same for on this side. And then the question is, what fraction does this take up? There's a bunch of ways to do this, but just for the sake of not making this a 40-minute long video, I'm going to suggest that we imagine that line right there, and maybe even that we drop altitudes here from both of those points. And pretty clearly here now you can see that the blue area here and the white area here are equal in size. Same here and here. Same up here. And that means that this is 1/2 of the whole square because they're the same size. You have to make sure they're the same. But you could then write some sort of description here like this, saying that the blue and the white areas are the same size. Now, this is probably not enough without some drawing over here. So you might want to add some other things here just because you want to make sure you have a reason. And my reason here is that I can clearly see this is a rectangle and those are divided evenly. Same thing here, etc. There's other ways. Please let me know if you have other ones. This was an interesting one in class. People noticed pretty quickly. So the question is, what fraction of the square is shaded? This little blue triangle right here. People noticed pretty quickly that those were all equal, and then they also said there are 1, 2, 3, 4, 5, 6, 7, 8 pieces. So a lot of people said there's 1 out of 8 because 1 out of 8 pieces are shaded. But I think that what's useful to practice here is also noticing like the blue triangle that's already shaded and this green one that I'm shading in right now, are those the same size? Because you really have to argue, it doesn't matter if just 1 out of 8 pieces were shaded, right? If I had a square over here and I had like 1, 2, 3, 4, 5, 6, 7, 8. Yep, there's 8 pieces there. If I shaded in this piece, you wouldn't say 1/8 of this rectangle was shaded because they're not equal sized pieces. Over here, you need to prove that they're equal sized pieces, which you can do if you notice that if you think of this as the base and this as the height of that green rectangle and this as the base and this as the height of that blue rectangle, that kind of like the problem we had before with these 3 rectangles, that these are the same size, they're just different shape, just as these are the same size and they're different shape. So you do want to add something like, and because they have the same base and height, they are all equal in size. the triangles. Okay, so now we want to know what fraction is shaded here. And it's really important to note right away that this orange and this blue, if you add them together, you're almost exactly going to get this. There's a little rounding because if you actually added these together, 581 times plus 581 or times 2, you're going to get 1162. But there's just a rounding issue that Desmos is doing that's causing it to be a little bit off. So this is actually an equilateral triangle. And because of the way that things are laid out, where this is half and this is half, you can know that these are midpoints. Okay, so the question is, how much of this is shaded? Well, this right here is smaller than this area, and it's not the same shape as this area, so I can't go straight to thinking like it's 1/3 because all three pieces are not the same size. One suggestion is to add the midpoint here, where this and this would be equal in size, and then just kind of imagine this lovely triangle here. If you do that, then you can see there is 1, 2, 3, 4 triangles that are actually all equal in size, and you know that they're the same size because the midpoints make them all like this length and this length are the same. This one and this one and this, they're all equal in size. And then you're actually getting somewhere because this triangle right here that's kind of outlined in pink and that right there is definitely the same size as this one. And also notice the blue is taking up exactly half of each of, like, this blue right here is the same as this white area. This blue right here is the same as this white area. And in fact, you could almost imagine taking this blue and kind of filling it in right over here. So like get rid of this and like move it over here. That would lead you to say that this is equal to 1/4 of the whole triangle. There are some other ways of doing it. This is just one of them. By all means, share if you have others. And the very last one. This is a square inside a regular pentagon. Regular means that all of the sides are the same and all of the angles are the same. These are midpoints. That means that this and this are the same size as this and this, so we can mark those as being equal. And that's actually one way to figure out this missing angle right here. I know since this is a square that that's going to be 90. All of those are going to be 90 degrees. 90. And if I could get this one right there, that would be so handy because then I could say, well, these three together must equal 180, and that would get us there. So we're going to use this triangle right here. I'm going to label it A, B, C, and I'm going to draw it over here again. What's handy is since these AB and BC are equal in length, that means that this angle and this angle must also be equal in length. And we know that all three of them have to add up to 180. So I can pretty quickly say that 180 minus 108, which is 72 degrees, has to get split evenly between those two angles. So if I say 72 degrees divided by 2, I will find that each of those is 36 degrees. You can double check yourself by adding 36, 36, and 108. That gets 180. Then I'm able to see over here that this angle right here would be 90 plus 36, or 126 degrees. And thus the orange angle right here is going to be 180 minus 126, which is 54 degrees. Let me know what questions you have. I know that was a lot. I hope this was helpful. Have a great weekend.